We start is I'm going to color code the vertices. So it says R corresponds with T, so I circled those in purple. It says S corresponds with U, and then W corresponds with V. It matters what they say here in the congruency statement, how you answer the questions. Okay, so just make sure that when you're saying what corresponds with SW, so SW is blue-red, the next side is blue-red. So you're going to say segment UV. And then angle U is blue, so it is congruent to angle S. And angle RWS. So angle RWS is technically another way of saying that angle would be angle W. So that's going to correspond with angle V. But you can't just call it angle V. So if you do RWS, you have to do TVU. Okay? So just make sure they're going in the right order based off of what they give you in the congruency statement at the beginning. Okay, now number 2, it says to find the length of AB, it tells you at the beginning that the triangles are congruent. So if the triangles are congruent, that means their segments are all congruent. So if AB corresponds with DE, then those would be two equal segments. So all you're going to do is just take whatever it gives you for AB and set it equal to whatever it gives you for DE and do math. So we have 6V minus 5 equals 4V plus 5. Okay, and then it's up to you how you want to solve. So Eric, what do you want to do?
I would like to move the, what I do? Yeah, you should move the 4V.
Okay, so subtract 4V and then?
Add 5.
Add the 5.
So 10?
V is 10. 5.
So divide by 2, V is 5. Now, does it say find V?
No.
No, it says find
The length of AB.
AB. So we're going to just go back and plug this in for V into here. So you should get 25. That's your answer. Yep.
Then keep that at. Guess my phone's
So for number 3, you have 3 triangles. We're going to try to figure out which ones are congruent, if any, and then why. So, alright, let's just look at the first 2. So this one only gives us an angle, side, angle. This gives us a few more things. So it gives us an angle, a side, an angle, and then another side. Now, is this triangle's angle, side, angle the same as one of this guy's angle, side, angles?
It could, indeed.
Yes, yeah, it is. So if you look at this angle, this side, and this angle, that is going to correspond with this angle, this side, and this angle. So we can say that triangle UTV is congruent to triangle FGH by angle, side, angle. Okay. So
that first time that's a V?
is it? Yeah, this is a V.
That's a, oh my gosh.
It's supposed to be a V at least.
That's definitely you.
You looked at it,
Oh.
but okay.
Oh, I mean, it just didn't copy well.
Wait,
Yeah, that's
which
an
one?
R.
Oh, crap. Okay, yeah, it is.
Oh,
Oh, I see.
I got that one wrong.
Well, there might be more. So I'm going to erase what I have here. So now I'm going to compare these two. So are these two congruent in any way?
No.
No.
No, because this is angle, side, angle, and this is angle, angle, side. So not those two. Okay, so then now let's check this one and this one. So is the first one and the last one congruent in any way?
What?
Side angle, side.
Well, this one, so this one again has an angle, a side, an angle, and a side. This one has angle, angle, and side.
Side angle or
Angle, angle, side, right? So if you look, it's got the single swoosh that this one has. It has the double swoosh. And then it also has this single side right here. So these two are going to be congruent by angle, angle, side. So triangle, let's say UTV is congruent to triangle, what do we call this guy? CBA by angle, angle, whoops,
AAS.
yes, side. So now, in theory, if triangle 1 is congruent to triangle 2, and triangle 3 is congruent to triangle 1,
Transitive property.
so which two are going to be congruent by the transitive property? 2 and 3. Yeah.
FGH is
So triangle FGH is congruent to triangle, what's that last one? CBA by the transitive property. So this is a pretty complicated one. The one on your test is, I think, a little bit less complicated.
Yeah, I only got one. I thought it was
Yeah, I
was
know.
gonna ask for one.
I know, so that, yeah, right, you just didn't expect all three of them.
Yeah.
I know. So the one I put on your test is maybe a little bit more, a little bit less difficult, because I put a series of different kinds. So basically, what you should be prepared for is being able to look at two triangles with the marks on them and being able to determine, are these congruent by side, 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 angle, or angle, angle, side. So just with pictures, like 2 at a time, instead of like all 3 and then the, you know what I'm saying?
Yes.
Okay. Questions? No. Okay. All right, number 4. What is, I think we did this one yesterday, what is the common side in ABD? So that's this triangle here. And DCA, that's this triangle here. So where did they overlap?
AB.
Segment AB.
Right. Good.
I said segment AB is linked to BA. Is that okay?
Yeah, that's good. Okay, then the next one says ABD again, but this time it says BAC. So where do the purple and the pink overlap?
BA.
AB or BA? Either one is fine. Okay, good. Okay, ready? Keep going. All right, so this is the system of equations one. So you have 2 triangles. You know that in order for them to be congruent by hypotenuse leg, the hypotenuses have to be congruent and the legs have to be congruent. So like one pair of legs. So you're going to take the purple legs and set them equal to each other. And then you're going to take the yellow hypotenuses and set those equal to each other. Now, you're going to pick one of the equations and make sure that it is solved for one of the variables. So, for example, you should have x equals stuff or y equals stuff. Sometimes you're already given that. Are we given that? No?
Yes,
Yes.
we are.
It says x equals stuff. Okay, let's pretend for a second that we didn't have that, okay? We would maybe go to this equation and we would solve it for y. So how would you solve this for y?
Minus 1.
Yeah, so you'd get x minus 1 equals y. So that's what you would do if you weren't already given something already solved for. Okay? Now, we don't have to do that for this question. We can just take this guy right here and plug him in to x for the other problem. So instead of it saying x plus 3, it's going to say y plus 1 plus 3 equals 3y. And then we've created an all y equation that we can solve. So I would start by just combining like terms. So we have y plus 4 here on the left. And then, yep, subtract y.
So every hypotenuse leg problem has a system of equations.
Well, no, but yeah.
Yeah. No, but yeah.
Yeah, I mean, no, not necessarily, but yeah.
Yeah.
It's gonna. So y is gonna be 2 here. Okay, and then all you have to do is just take this, plug it back in here, and you should get x. So x is 3.
X.
So we don't really need this for this particular problem because we already were, given x equals stuff. But another way would be to solve for y and then take this, you would plug it into y. So that's another way to do it. But we don't need to do that. Okay. Questions? No, no, no. All right, so you're going to have a question that has either an isosceles triangle, an equilateral triangle, some kind of triangle that has congruent things. So this is an isosceles triangle because you have this little mark here and this little mark here. So in an isosceles triangle, if the sides are congruent, then the angles across those sides are also congruent. So these two angles, the base angles, are congruent. Now, in addition to that, the problem has already told you that these two angles are congruent. See how it's got the congruent marks? So we know that as well. Now, there's a few ways we can solve this. First, I'm just going to start with the easy one. This is y. If this is an angle bisector, y is going to be the same as this segment over here. So y is 4. Because this angle bisector is not only bisecting this angle, but it's also chopping this segment in half. Now to find x, you could do this a couple of ways. I'm going to do it one way, and then if you have another idea, we can look at that. So I said that these two base angles were the same, so they're both 52. So if you look at the whole triangle, we have two angles that are 52, and we have one angle up here.
That's around 90.
That is, no, this one up all the way up here. This one up here, that is made up of two x's. So you got this x here, and you got this one over here that's the same size, so it's 2x. All of those have to add up to 180. So you see that, so if this angle is x, then this angle is also x. I'm just calling the purple angle 2x because it's both of the x's. So that makes this 104 plus 2x. And then if you subtract 104, 76. And then divide by 2. There you go. And there you go. You can plug it back in and check, I guess.
Wait, so even though to show your work, like y, it's just like that, you can just write y equals 4.
Y doesn't, yeah, you can't really show your work for that one, I guess. This is theorem 4.5 that allows you to say that y is 4. So if you want to go back and check on your theorems. One thing that is going to be on this test, I told you briefly, but just a reminder, vocab. So it's not all the vocab, it's the theorems. So I need you to know what the theorems say. So go to your vocab list. There are theorems like, even like the postulates, like side, side, side postulate. What does it say?
If three sides are congruent, then the triangle is congruent.
Sort of, you're abbreviating, but yeah, basically.
Oh.
So you need to be able to look at what it says and then identify what or which theorem or postulate it is. So that way I think is actually easier because you can kind of decipher. So it's going to give you a definition and then you're going to tell me what theorem or postulate that is. Okay? So like theorem 4.5 for example. Alright, so then these are proofs. So on your test, you have one question where you're given all the reasons, one question where you're given all the statements, and then two that are blank. But I give you the boxes, so that's helpful, I guess. So if you can do them all naked,
So it's not completely.
then you're going to be awesome.
Why can't do
Nikki! Alright, so what's the first part of every proof?
Given.
Given.
1%.
Eric.
Actually, more.
How much is like each problem? Is it just if you get something wrong, it's completely wrong, or do you have like half points?
I mean, if you put the given, you'll get a little some.
So like 0.2.
Yeah, maybe, I don't know.
All right, 0.2 points in, boys. Hey, you can also always get the proof.
In this particular question, what has been given is marked in the picture. If it's not,
Then you mark.
you mark it. So if it says angle A is congruent to angle C, I need you to take your marker or your pencil or whatever you're using and go in here and mark them congruent. I promise this will help with the proofs. Okay? So ours is already given, so we don't have to do that. Now, it says that they're right angles. When they tell you they're right angles, you're probably gonna say that they're congruent, right? So that's what we're gonna say. We're gonna say angle ADB. Whoops, I missed the D.
Oh yeah, right angles are congruent.
So angle ADB is congruent to angle CDB because right angles are congruent. I would say that's the longest reason.
And then you can do
Reflexive property.
reflexive on
Yeah.
BD, so you can get angle side.
So when you do it, put the mark so that you know what to use after that. So BD is congruent to BD. Okay, and you know you can say it that way because if you look up here in the congruent statement, it says A, DB, and C, DB. So D and D are corresponding and B and B are corresponding. Okay, so reflexive property, and then Eric, you said angle, side, right?
Mm-hmm.
Okay, everyone agree? Yes? Correct. All right, so triangle ADB is congruent to triangle CDB by angle, side.
I wasn't far off. I just forgot
Situation.
because you're gonna get the
Side angle's not a thing, remember?
Oh, angle.
Side angle side.
Side angle. No, yeah.
Yeah.
Side angle side.
Let's take our time, no rushing. We'll write our givens.
All that matters is I got it right. So.
Okay, those are
I
givens.
missed a step.
This one's a little bit longer than the other ones, okay? After saying that this angle is 90, you need to say that this angle is 90. Okay, and that's going to take a few steps.
Linear pair.
So, yeah, so you're going to say the measure of angle PNO plus this guy, who is 90,
And
is equal to 180 because you just said linear pair postulate. It says angles that form a
Can you do
linear
LPP?
pair are supplementary.
Can you do LPP?
Can you do, say it again?
LPP.
LPP, there is no L.
Linear pair postulate.
Oh,
LPP.
no.
Obviously not.
That's not a
After
thing.
all that.
Yeah. No, that's not a thing.
Not misrepresented.
Okay, now we're going to,
Minus prop.
yep, we're going to subtract 90 and
I feel
say,
like that was like an almost given though. I didn't put it in my thing, so that's probably wrong. Or could you
Yeah,
say
you
that
gotta
right
do
angles
these
are
two.
congruent? And
you're
just
going to say that next. But first you have to say that
You have
this
to
is a
make
90-degree
sure.
angle. Yeah. So first you have to say this is a 90-degree angle. We have said that now, so now we're going to say angle PNM is congruent to angle PNO because right angles are congruent.
And then it's the same thing as the last one.
Wait, what? You just,
No, it's not. It's different.
No, but like
It's SAS.
I get that it's SAS, but you
But it's
go-
not, actually. So keep going. So what's next?
Tyler.
What's
You said
next?
it, not me.
PN is congruent to the NP because of the reflexive property.
But you don't have to switch them. You can just say PN is PN.
But I'm accustomed.
So PN is congruent to PN by the reflexive.
HL.
Yeah.
Hypotenuse, right.
Good. Look at Tyler. Keeling it. Yeah, so this one's not, look, it's side, I see what you're saying, it's side angle, and there's another side here, but it's not side angle side. In order for it to be side angle side, we would have to have this one.
Yeah, I
And
knew
this
that's what
one.
it was gonna be.
So
You
it
could
doesn't
say
work.
midpoint, though.
No, but it didn't tell you it was a
Oh, yeah.
midpoint, so you can't.
Okay, I got
So that would be cheating, and nobody likes a cheater.
Well,
it. Wait, that's not cheating. It's just getting it wrong
Well,
yourself.
define cheating.
It's just choosing to get it wrong, but still having a decent reason.
Define cheating.
So it's going to be the hypotenuse leg because we have a
See.
hypotenuse, and then this would be the leg that we have.
I see it.
In general, if they're right triangles, you probably should be like keeping an eye out for a hypotenuse leg just in case. But that doesn't necessarily mean you're using it. But, you know, it could happen for you. All right, so just to point something out, if the prove doesn't say triangles in it, then you know you're using CPCTC.
well, I was just gonna say that.
So you know the end, okay? But let's not put it in yet. Let's put the given. So it says BC is congruent to EC, and then it also says AC is congruent to DC. Okay. Do you see marks on the triangles that say that?
No.
No.
Therefore you should put it.
Therefore, you should put it in. BC, EC, and then AC.
It's almost like
DC.
second equal
It could also, so this question could have been phrased, C is the midpoint of AD and BE to make it harder.
No.
Or BE and DA bisect each other to make it harder.
No.
Then you would say they were congruent either by the definition of midpoint or definition of bisector. So to make this harder, that's what it could have said. Just letting you know. Okay,
Well, Ms. Rapp, I already know the answer.
what comes next?
Vertical. You could say vertical angle theorem.
Yes, no, you want to say vertical angle theorem. That's
Okay.
good.
Well, I have the answer, Ms. Rapp.
So just when you put them in, you have to be careful now. This is why the markings help. So BCA corresponds with ECD. So angle BCA is congruent to angle ECD by the vertical angle theorem. Vertical angles are congruent.
Bad.
Okay. Do we have enough information to prove the triangles are congruent?
You do.
Yes.
Just
Why are they congruent?
CPCC.
No.
You have a free life.
Definition of a midpoint.
Look, what do we have?
Side angle slide.
This is a
SAS.
side. This is an angle. This is a side.
Yeah,
Yes?
sassy.
So
Sassy
SAS.
and it's
I wasn't
Okay,
too far
your
off on that,
last
too.
reason CPCTC, and that's where this comes in. So now we can
Oh,
say,
no, I thought that's what we were on.
oh
I
no.
thought that was the last one.
No, we're not
So
there
I'm
yet.
basically right.
You always have to prove the triangles are congruent before using CPCTC. Because remember, that stands for corresponding parts of congruent triangles are congruent. If you don't have congruent triangles,
They don't have
then you can't use
CPCTC.
CPCTC.
See.
It doesn't make sense.
no sense made.
Okay, so last one. Meh. Meh. Okay, so angle PRS and angle RPQ are right angles. And then SP is congruent to QR.
Yeah.
Given.
2 points.
Wait, what is that little thing? Oh, and.
An ampersand. I like to abbreviate. Okay, those markings are there, so that's good. What else can we say?
Angle R and angle Q or P are congruent. Because right angles are congruent.
Okay, we can't call that R and P though. We have to
Oh,
call it,
PRS
yeah,
and the other one.
oops, RPQ. So right angles are congruent. Our favorite theorem, yay! All right, what else? Good. PR is congruent to RP. And yes, this time you have to switch because they're vertically flipped of one another. Well, if you look, R corresponds with P and P
So wait,
corresponds
when
with
do you
R.
flip them?
Look at the
Just
congruent.
always flip them.
No, look at
That's
the
what I do. It
no,
sounds
because
right.
then you no, it's not.
When is it not right?
In the last 3 questions.
Yeah, no, you don't.
You
You
said it
just,
was fine though.
No, I didn't.
Oh.
I said don't do that. Look at the congruent statement. Do you see how P and R are both first?
so it'll say it in that.
It will say it in the congruent statement. Yeah, if
Oh,
they're
okay.
flipped here, then they're going to be flipped here. And if they're not flipped there, then you don't flip them there. And so then, reflexive, right?
Hello, why are you sticking which one out here?
What are you talking about?
Do we have enough information to prove the triangles are congruent?
Yes.
By?
Side angle side. Why am I lying?
It's
What?
HL. Hypotenuse leg.
This game is rigged.
I know. You have to be careful with your sass. Because we do have a side, an angle, and a side here, but it's not the included angle. So we can't use sass.
Okay, I'll be going back to algebra 1.
Algebra 1.
Or I'll go
No,
I'll go
I'd
back
rather
to
stay in
class.
geometry.
Yeah, big facts.
Freak algebra, man.
You're not
Yeah.
a fan of the algebra one?